All right, let's look at graphing in vertex form. So that's the form f of x equals a times x minus h squared plus k. So there are multiple forms that we can write a quadratic in, right? We've seen ax squared plus bx plus c. That's what we call standard form. And that makes it really easy for us to see our y-intercept, because we know that when x is 0, y will equal c, right? In other words, we know what our y-intercept will be, because a times 0 squared is 0, b times 0 is 0, plus c, meaning when x is 0, y is c, and that would tell us the ordered pair for our y-intercept. So that's one benefit to writing something in standard form. Now, this form here that we're looking at is what we call vertex form, and it makes it very easy for us to see our vertex, because when we have something written in the form a times x minus h squared plus k, h will be the x-coordinate of our vertex, and k will be the y-coordinate of our vertex. So for example, if we had f of x equals 3 times x minus 5 squared plus 3, we know that our vertex would be, again, hk. So h is 5 and k is 3, and that's where our vertex would be. So I also want to show you just what a translation of our parent function f of x equals x squared looks like from this format. So in black here is a graph of f of x equals x squared. Remember, that is our parent quadratic function. And we can see that with this blue function, g of x equals x plus 3 squared minus 4, that we have translated 3 units to the left, right? We've got that plus 3, which means h is negative 3. So we go 3 to the left, and then we have minus 4, so we're also going to then shift 4 units down. So we've translated 3 units to the left and 4 units down. And you can tell here that our axis of symmetry would be at h, so x equals negative 3, and our vertex would be at hk, negative 3, negative 4. Now let's look at graphing 2 of these. So f of x equals negative 2 times x plus 2 squared plus 3. So the first thing we can do is plot that axis of symmetry, because we know it's going to be at h. So our axis of symmetry, again, the format is a times x minus h squared plus k. So when we have addition here, that means h is actually a negative value. So our axis of symmetry is going to be at negative 2. Then we can go ahead and plot our vertex. We know that our vertex is at hk, so that means negative 2, 3. So there's our vertex. And then we can use our equation to plot more points. So we're also going to use our axis of symmetry to help us out here. So let's go ahead and find 2 points that are to the left of our axis of symmetry, and then we can use the axis of symmetry to plot 2 corresponding points to the right, and then we'll have a total of 5 points to graph this quadratic. So we have negative 2, again, times x plus 2 squared plus 3. So let's solve when x is negative 3. So negative 3 plus 2 is negative 1. And negative 1 squared is 1. So we have negative 2 times 1, which is negative 2, plus 3. And we get positive 1. So when x is negative 3, f of x is positive 1. So we can go ahead and graph that point. Then we can graph another one. So let's solve when x is negative 4. So when x is negative 4, we have negative 2 times negative 2 squared plus 3. And we know that negative 2 squared would be 4. And negative 2 times 4 is negative 8. And then negative 8 plus 3 is negative 5. So when x is negative 4, f of x is negative 5. And then, like I said, we can use our axis of symmetry to plot these corresponding points. So we know that we would have a point here at 3, 1, and a point here at 0, negative 5. And now we can draw the graph of our parabola. Alright, so let's graph this next one. F of x equals 1/2 times x minus 4 squared. So again, we can see our h value here is 4. So let's graph our axis of symmetry at x equals 4. Now for this one, again, remember the format would be 1/2 times x minus 4 squared plus k. And we don't have a k value here, so we know that k equals 0. So our vertex would be at the point 4, 0. Now again, we've got our axis of symmetry, so let's plot 2 more points, and then we can find the corresponding points on the other side of our axis of symmetry and go ahead and graph this. So let's start, and let's find f of 2. So f of 2 will be 1/2 times 2 minus 4 squared. We know that 2 minus 4 is negative 2. Negative 2 squared is 4. So 1/2 of 4. So we know that when x is 2, f of 2 is 2. So we can plot that point here. And then we can also find f of 0, which will be 1/2 times 0 minus 4 squared. We know that 0 minus 4 is negative 4. And negative 4 squared would be 16, and half of 16 is 8. So we have the point 0, 8. Now if I extend my graph a little bit this direction, I should have a point at 6, 2, and at 8, 8. And now I've got quite a few points that I can use to help draw the parabola.